Okay, see Lindelof videos reviewing operations with square roots. Today I thought we'd talk about division. So let's talk about division of square roots. The same thing would be true as long as they're common roots. So we're going to work on division a little bit today. Look, just a couple little rules here that we have to know. It's just really simple stuff. That the square root of a times b is exactly the same as square root of a times the square root of b. This is important because we're going to do this later. I'm going to look at this a lot later. And then also, the square root of a over the square root of b is the same as writing the square root of a b. Remember, these rules are reflective. Reflective means they're the same one way or the other. So it's true this way, right? This is really important. It's true this way, and it's also true this way, the same thing. And you're going to see this a ton in calculus, where you have these rules, and they are true one way or the other, and you have to figure out which way do I need to use this rule. So, and the other thing that we have to think about also is this, that no radicals in the denominator, no radicals in the denominator. Super important because you're going to get something simplified and you'll be like, I got this. And then it's going to come back as wrong. You're like, what the hell just happened? And what the hell just happened was that you can't have this. So you can't have a over the square root of b. When you're finished, all the radicals have to be out. So you have to figure out, how am I going to get this radical out of here, right? Not allowed. No radicals in the denominator. We're going to get to that, I promise. Let's just get to work a little bit. So all we're going to do is this. We're going to take this problem, right? So we have the square root of 12 over the square root of 4. You're like, why are you writing it twice? I don't know. Makes me super happy. So I'm going to take this, and I'm going to use that rule we just talked about, and I'm going to take these radicals right here, right? I got a radical down here, square radical here, and I have a square radical here. So I'm going to take this two radicals, I'm going to put it under one radical. Crappy looking radical. 12 over 4. And then the reason that this is a good thing to do is because if you do this, then you can take this piece of 5th grade math right here, you can drag this over here, and you can start to simplify this. Like I got 12 divided by 4. 12 divided by 4, I believe, is 3, right? 12 divided by 4 is still 3? It's 3. So what we have here, I have to put this back under the radical after I simplify it. So we really have the square root of 3. Say somebody's on the MCAP or whatever test you're taking, you're asked this question, how do you simplify this? So you're going to simplify this. This is the simplified solution to this, right? So let's go to another one quickly. Check this out. This is the same kind of weird thing, and all I'm going to show you is this is called partitioning. So can you see the 2 over 4 here? So I'm going to take this 2 over 4 here, right? I'm going to partition it out, and then I'm going to take this square root 3 over square root 27. Now if you can just, oh, that's the 27 over 24. Boy, genius. Right? 27 here. So if you can check this out for a second, if I multiply these two things back, I get my same answer, right? Nothing happens. But when I partition it, I know that 2 over 4 is 1/2, isn't it? So I have 1/2. So I simplified this. Now, I'm going to do what we talked about in the last problem. I see the square root here, and I see a square root here. So I'm going to take 1 square root of 3 over 27. Hopefully you can see that that can be simplified. I'm going to drag this piece out, do my 5th grade math. 3 divided by 27, right? Divide the greatest common factor of the 2 is 3. And we get 1 over 9, don't we? So just keeping with what we have, I'm going to take this 1/2 is this one, so here goes this 1/2, and then I'm going to do this. I'm going to say, okay, square root 1, I'm taking it back to this form right here, square root 1 over square root 9, and this actually works for us. Square root of 1 is 1, 1 times 1 is 1, square root of 9 is 3, 2 times 3 is 6, so when I simplify this, I get this solution. So simplified is, right? So here's the simplified version. Simplified. We good? Trying not to take too much of your time because I know you have other stuff to do. All right, let's look at this one. I know you can already see this, right? You see the 3/4 here? I'm going to take the 3/4. I'm going to leave it there, 3/4. And I'm going to say I'm just going to do this as one thing. Square root here, square root here. I'm going to take one square root. Square root of 20 over 16. Same thing. 20 over 16 simplified is, what is that? 5, is it 5/4? Yeah, 5/4, right? 5/4. Go back here. 3/4 times square root 5 over square root 4. It's really good for us so far because this crap keeps working out because we know what the square root here is. Square root of 4 is 2. So I can simplify that out. When you multiply, right, this is not a square root. So when you multiply, it just goes, it actually turns out to look like a coefficient. I get 3 square roots of 5. 4 times 2 is 8 over 8. So this simplifies that. We good? I'm trying seriously to keep this really short because I know, again, you have something. Oh, so here's a great example. So we have square root, right? 25 over 15. Thank God, here it is. 5th grade math, 25 over 15, right? I changed this under one radical so I could do this. It's 5, isn't it? So I get 5, and then 15 divided by 5 is 3, 5/3, right? So check this out. This is where it gets to be some crap. So I'm going to put these back under the radical in this form right here. So I'm going to return that form and I get square root 5 over square root 3. But we talked about it in the notes that you're not allowed to have a radical in the denominator. You can have one in the numerator, but you can't have one at the bottom. So it's really easy to get rid of this. It's super simple. Whatever you have inside the radical here, you take square that same thing. So square root 3. It's on purpose because, right, a number times itself is its own square, right? And then I did square root 3 down here, so square root 3. And if you're wondering, Lindelof, how come you can do that? Well, 3 over 3 is 1, and 1 is the multiplicative identity, which means it doesn't change anything. Remember, we talked about this, that the square root of A times the square root of B is equal to the square root of A times B. So 5 times 3 is 15. The radical comes with it. Radical here. But check this out. This cures our problem. This cures that radical in the denominator. 3 times 3 is 9. Square root of 9, right, is 3. So this thing cleans up really nicely, right? The square root of 9 is 3. So our simplified answer is square root 15 over 3, right? Check this out again. Super important to remember. You're allowed to have a radical in the numerator, but not in the denominator, right? It's called curing the denominator. So we cured the denominator. Do we want to do even one? Let's do, like, seriously, one more problem. Oh, so same thing. I see a square root. I see a square root, so I'm going to make a big square root. 15 over 6. 5th grade math. 15 divided by 6, right? Divided by 3, divided by 3, right? This is 3 over 3 is 1, so we're allowed to do this. 15 divided by 3 is 5. 6 divided by 3 is 2. So go back to this crap again, right? I'm going to put it back into this form. The last thing I do is put it back in this form. So I got square root 5, that's this 5, over square root 2, that's this 2, from our simplified fraction. And you can see again that there's an issue here. We have square root. We have a radical in the denominator. So I'm going to multiply the same radical by the same radicand. 2 is the radicand. You see these are exact matches. Over be careful. Square root 2, right? Have to make sure these match. So we're multiplying by 1. Multiply fractions straight across. We get 5 times 2 is 10. We get square root 10. Square root 10. And then we have square root of 4. And seriously, we know that the square root of 4 is 2, right? So I took the square root of 4. I made it 2. And that's why we did it that way. So hope we have this figured out. And somebody I know is asking that question. You're like, what about this? What's the square root of 10? I don't know. So if you look at it and you're like, I have no idea. I don't know what the square root of 10 is. That means it's not a perfect square. So all we can agree on is that the square root of 10 is the square root of 10, right? Square root of 4 works out great because the square root of 4 is 2. Square root of 16 works out really good because the square root of 16 is 4, but this doesn't work out cleanly. So when you see this, you're like, I don't know what the square root is, you leave it. So the simplified version of this is this. All right. So see Lindelof videos. Thanks for watching. If you haven't already subscribed, please do. And thanks for watching. Peace.